In the last lecture, we have studied electron gun to produce fast focus beam of electrons. And today we will study one application of this electron gun, CRT, cathode ray tube. How this electron gun helpful to us to develop a cathode ray tube, a CRT, where we can visualize many things. Up to extent we have developed television to visualize faces, to visualize many things. Here we will discuss the principle, construction and working of these things in detail. The aim of the lecture is to learn the details about cathode ray tube. What are the parts of cathode ray tubes? How each part work, and what is the basics, what is the principle, construction of cathode ray tube, and finally working and applications. Cathode ray tube schematics is shown here. You can see it consists of several parts. Basically, first thing is it is a constructed vacuum tube, glass vacuum tube, in which we create electron beam and control by electric and magnetic field to generate visual display of input signal on fluorescent screen. Basically, this consists of several parts. This is first part used to generate electron. We have discussed this here. Now, this is your second part. This is used to focus anodes. These plates are used to generate visual display. This may be electric, may be magnetic. And finally, this is your screen where we see the output. Of course, we will discuss this aqua deck coating. This is used to control the axis of electrons. If you have too many electrons are there, so there may be a rush of electron on this surface, which can stop other electrons to come. So there is a passage to control the electrons here, to move these electrons outside. The cathode ray tube resembles a horizontally placed conical flask. Is it? Yes. And sealed at open end. The electron gun consists of filament, cathode, grid, and 3 anodes. This is first part. It is electron gun. This is mounted at one end of the tube as a single unit. The electrical connections are given to them through basic pins, already shown in the previous figures, lower side, top, bottom side. After this, we have second system, that is called deflection system, in which we have plates, two pair of parallel plates, and these are mutually perpendicular to axis of CRT. The screen consists of thin coating of phosphor. The phosphor coated on the inner surface of the wide end. As this electron can give fluorescence, this can be used to display. The inner surface is also coated with conductive graphite coating. That term is aquadag. You can see this on the slant areas close to screen. It is internally connected to accelerating anode. An additional electron will pass through this aquadag coating, conducting coating. Sometimes this may be asked specially, what is the role of aquadag here? What is the role of deflection plates here? What is the role of anodes here? What is the role of grid here? We can write few lines one by one on these roles. Electron gun, the indirectly heated cathode ray we have used here. Just to add, indirectly means here we are not giving supply to this cathode. We can also generate electron by direct supply or indirect supply. In the indirect supply, we heat the cathode, so thermionic emission will be there. Normally we use this method. Otherwise, we can get direct electrons also. This electron, stream of electron from its coated front face emitted, and the electron pass through the control grid. The control grid, as is clear from the name, it is used to control the passage of current. We keep it negative. The potential is negative. Why? Because electrons are already negative, and if you pass the electron through a cylinder of negative potential, then they will not scatter. They try to move in a axial direction, in the same direction. That is why you can keep the electron passage focused in a particular direction. The effective size of the aperture of grid depends on potential difference between grid and cathode. Aperture size can be managed by applying potential difference. If we put the negative potential too high, then there will be no electron passage, or you can reduce it to the, this can be set. The intensity of the glow on the screen is controlled by number of electrons striking on the screen. Therefore, by controlling the grid voltage, the number of electrons striking the screen can be controlled. Thus, the brightness of spot can be controlled. The anode A1 and A3 are internally connected and held a high voltage potential, few kilovolt, and A2 is maintained at relatively small potential. Anode A1 accelerates the incoming electron and A2 and focusing anode. The anode A3 is impart the further acceleration of the electron beam. By adjusting the potential of anode, A2 focus of the beam can be adjusted. The electron emerging as a narrow beam from the electron gun and move towards the screen. On the way, they pass through the deflection system. We can take two types of deflection system, electrostatic type or electromagnetic type. If we use only metal plates implied, then it's called electrostatic. This is used to deflect the system. One pair of plate is arranged horizontally near the anode A3. When a potential difference is applied between the plate, the electric field is produced in vertical direction. And these plates are called as vertical deflection plates or Y plates. When a DC voltage is applied to Y plates, the electron gets deflected vertically. We can also apply another plates and to the vertical to the x-axis. They produce electric field in horizontal direction. These plates are called horizontal deflection plates or X plates. They deflect the electron in horizontal direction. A set of plates can be placed. When no voltage are applied, the deflection plate of the electron travel to the axis and strike center. So by varying the voltage on the plates, you can move the spot, luminous spot. Why luminous spot? There we have fluorescent coating. So luminous spot may be checked. Fluorescent screen is the top right hand portion of the CRT. Actually, a translucent layer of phosphor is deposited here. The phosphor glow at the point where it is stuck by the electron beam. As using X field and Y field, you can move the electron everywhere on X direction and Y direction. So you can see the motion on the fluorescent screen. Aquatic coating I have discussed. We use as electron impinging on the circuit on the screen tend to charge it negatively and hence causing repelling of electrons coming afterwards. If they repel the other electrons, this will result in decrease of electrons reaching the screen and hence the brightness of glow reduce. The electron striking the screen not only cause the emission of light but also produce secondary electrons. And the electrons gradually resume a positive charge as electrons are emitted from it. Hence the aqueduct coating is used to remove excess electron and return to cathode ray ground. The deflection sensitivity limit of the electrostatic deflection. The deflection sensitivity of an electron in an electric field is defined as S is equal to LD over 2D VA. In meter and millimeter, 500 LD over dVA, millimeter per volt. And the total spot deflection is defined as deflection sensitivity into applied voltage between the plates, where L is the length of the plates and D is the distance between those. The angle of deflection of the electron beam in electrostatic type CRT is defined as theta tan inverse LD over 2 dVA. Theoretically, a large angle deflection can be obtained by selecting longer deflection plates. If you have large length, and keeping them closer, small d. For the formula, you can deduct. But in practice, the deflection theta has to be restricted to smaller values. Otherwise, the electron might strike the deflection plates instead of the screen. Because of the restricted angular deflection, the area that can be covered by the electron beam on the screen become smaller. It is thus not possible to obtain bigger display using electrostatic deflection. All the screen cannot be used for to observe the electrons. This limitation has been filtered or modified by new type of screens as we are nowadays we are using LEDs and other screens. This was the drawback of the old screens.